Hi guys, and welcome to your second tutorial on household circuits. Again, guys, this is a chapter where I can't really help you much because it's just learning stuff up and understanding it. So it's all up to you. However, I'm still going to do certain basics, and most probably I'm just going to be telling you what are the important concepts. So guys, now that you're watching this video really close to your examination, don't worry, you still have time. First page, that's the section C, 225 page number in my textbook of concise. It's talking about fuses, guys. Fuse, as I'm hoping you already know, is a safety device which is used to limit the current in an electric circuit. So, the use of a fuse safeguards the circuit and the appliances connecting the circuit from being damaged. Very easy but important definition to be, um, you know, learned up because it's highly probable that they ask you as to what a safe of or what the safety device fuse means and how is it connected in the circuit and what is it made up of. Now, what is it made up of? It's made up of high resistivity and a low melting point material. It's usually lead and tin, if I'm not wrong. So that's about it in the fuse part. Now guys, next comes the working and the construction of fuse. You can read it up yourself. Construction is I don't think it's really important, but you still should know, you should get familiar with the diagram and the working. It's just that whenever there is short circuiting or voltage fluctuations, the fuse wire, it breaks and it stops the current from moving through, and therefore the plants is saved from being damaged. Next comes, guys, the reason as to why fuse is connected in the live wire. The reason for this is that if at all the fuse was connected in the neutral wire, the neutral wire, which is responsible for bringing back the current, the backflow of current, would be damaged, and therefore the plants would remain at a high potential. So, in order to not, in order to save the person from being electrocuted, if at all there is an excess flow of current, the current should go back and the plant should not remain at a high potential, and which is why we always connect the fuse in the live wire. Current rating of a fuse is very easy. You should just read it up yourself. The entire concept is just P is equal to VI. Again, next comes again a really easy and important subtopic, which is miniature circuit breakers. Now, guys, they've replaced the fuses now because they switch off the circuit in a very short time duration, and also that it people can avoid the misery and the time consuming job of repairing the fuse and putting in a new fuse by using an MCB, because the MCB it has strips, it has switches in it. So whenever there is an excess flow of current, it just goes down, and you can always turn it up. So guys, don't look at the screen right now, just hear my voice, just close your eyes, I'll tell you when I start writing. So that's about it in MCBs. Now comes switches. Switches, again, you learned this in class 9. Switch is an on-off device used for current in a circuit. It is connected in the live wire, guys. Now, what is the reason that the switch is always connected in the live wire? Guys, simple reason, same reason as connecting the fuse in the live wire. So if you actually have a switch in the neutral wire, which is responsible for bringing back the current, the switch will perform its function, that whenever it is in the off position, whenever the circuit is closed, current will flow and the bulb will glow if all the bulb is there in the circuit. Please see 227 page on which MCB is discussed. So yeah, so it will serve its purpose. However, the plants will remain at a high potential at the position when the switch is in an on position. So guys, this way the person can get electrocuted, and thus it is more sane to put the switch in the live wire. In fact, if you don't want to get electrocuted, then you should put it in the live wire. So guys, that's pretty much it in circuits. On switches also, next comes the circuits with dual control switches. I hope you've done this in class. I has given you a good diagram because the diagram in the book is not really good, and I don't think I'll be able to draw it right now. So the only thing is, guys, the only concept he's using is that so if at all you have I don't know, most of you must be having this in your houses. Whenever you have large staircases or otherwise, you have dual control switches. For instance, if you go down, if you just start climbing the stairs, you have a switch there. You switch it on, and you go up the stairs till you reach the top. and now you no longer want the light. So then you won't really want to, and you don't really want to go down because again you're scared of the dark. So you have another switch there at the top which switches off that light. So guys, same appliance connected to two different switches just to serve your purpose, because you're scared. So guys, just kidding. So guys, that's what dual control switches mean. And next comes earthing. Very easy. Please read it up yourself. I can't really do much. The only thing I can tell you is a copper rod, dug into the ground, 3 meter deep hole is dug in the ground. I'm just reading it out. It's really easy, and there's a mixture of charcoal and salt for better conduction. And another thing which is important is part B, which is earthing of an appliance. Now, guys, if you have a fridge or if you have an AC, so guys, if you have an AC or something else like a fridge, then it's usually most often the metal body part of the appliance is painted. So this paint provides an insulating layer, guys, on the metal body of the appliance. So to make earth connection, therefore the paint must be removed from the body part where connection is to be made. So whenever you need to do earthing, you have to remove that paint so that better conduction takes place. So now we come on to plug and socket. Very easy. The only tricky part here is sometimes they ask you to label the 3 pins or the 3 switches. Please learn it up. And please, it will be better if you take a real life example. Go next to a switch and then try remembering it, because I think image memory is the best for a physics paper. So guys, that's pretty much it about socket and plug. Just learn up the definitions, and the color coding of wires in a cable is really important. Live, yeah. Now please guys, wake up. See, look at the black screen, and now look at the green color on it. So guys, we've got live wire, we've got neutral wire, and we've got an earth wire. Oh yes. So guys, now the color coding is really important. Okay, please understand that the old convention, that's the O, and the new convention, that's the N. So the O, guys, is for a live wire. It used to be red. I don't know why did. And the new wire, the new color, guys, is brown. Right? Neutral, old color, black, and new color, guys, light blue. Oh wait, I have an idea. Where are my colors? Light blue. Alright guys, so this is light blue, and earth, which used to be green. I never understood what they meant by this when they say that it used to be green and now it's green or yellow. So sometimes the color's not changed and sometimes the color's changed. So anyway, you just have to learn it up because the ICS expects you to, and ultimately you're just doing this for the board, and we're doing this for you and charity. So it's good. So guys, now last important thing is the high tension wires. Last topic, very very essential, because sometimes you do have your questions in the paper. And okay, so all it means is, guys, that overheating sometimes, or excessive heating because of large currents flowing through a wire, it actually sometimes causes fire. So to avoid that, for high voltage and heavy current, guys, we use a special wire which is known as the high tension wire. I'm just reading it out from Concise. So a high tension wire has low resistance, guys. Just remember this, that a high tension wire, HT, has a low resistance and a large surface area. Now these two are the key terms. I am sure this is the question has been asked earlier in the board papers also. I remember seeing them. So guys, you have to remember the high tension wires are used to stop that overheating, to avoid it, and they have a low resistance and large surface area. One more thing you have to learn is that it is made by twisting together a number of thin wires. Now that's its characteristic. Instead of taking a large thick wire, they take a number of thin wires and then they wind them up together so that they provide a large surface area. That was our requirement. And large surface area so that it can radiate the heat produced more readily as compared to a single thick wire. So, guys, finally, with this, we reach the end of the chapter. I hope you're satisfied. I hope this is my speaking actually has helped you just before your examinations. If at all you need anything, please contact me or Karun. We will be giving out our contact numbers. Or, by the way, Karun is a genius. If you guys don't know, he got 96.8. He's your former topper. So that's one reason you should contact him. And another thing, you can always contact your teachers, guys. Please don't be shy. Please don't think that you will just be disclosing your low IQ if you think you have one in asking stupid questions in class. Please don't. At the end of the day, it's the board paper that matters, and it's your own concepts that matter in that board paper. So, guys, have fun and keep watching. Thanks a lot.